Alrighty, so the next thing we're going to do is we're going to move to equations where they are actually in a word problem. We're going to talk about what these mean with actual context from the real world. So our first example is going to be an example about shoes. I'm going to make this big. I know it's kind of over my head. Let's see it right there. So here's what it says. It says the equation 3246, so 3,246x minus 2y equals negative 152,722. Okay, so that equation can be used to estimate shoe sales in Europe from 2010 to 2015, where X is the number of years after 2010 and Y is the revenue in millions of dollars. So part A is write the equation in slope-intercept form. So let's start with just the writing the equation in slope-intercept form. Then we'll talk about more of what it means. Okay, so here we go. I have 3,246 minus 2y equals negative 152,722. Okay, big numbers here. Gross minus 3,246x on both sides because we want that x that has the slope to be on the same side as my number and the opposite side of my y. Those are too big for me to write and say out loud. All right, and then I'm going to go ahead and divide by -2 on both sides. Divide by -2. So now I have y equals, let's do this math together. So negative 3,246 divided by 2 is negative 1,623. My x is attached to that. And now I'm going to divide the other one by 2. So 152,722 over 2 is, we're going to have the minus sign. So then it's minus, wait, no, we don't have any minus signs. If we divide it by -2 and that's negative, and that's negative, then it's positive. This one's going to be positive too. Good thing you guys caught that. So glad. 76361. Okay, so again, we still have big numbers, but at least we've done the first part, which is write the equation in slope-intercept form. Okay, let's see what the second part of this question is. It says, part B, interpret the parameters in the context of the situation. All right, so what does that mean? That means what exactly are we even looking at? So let's draw ourselves a graph and think about what's happening. So we know that it's going to be an XY graph because it kind of told us we have an X and a Y. So here we go, an X and a Y. I said that backwards. This is the Y, this is the X. Okay. X is the number of years since 2010. So number of years since 2010. And Y is the revenue. So how much money are they earning by selling these shoes? Okay, we have a slope intercept of roughly 76,000. I don't think I like where I put that. I'm going to put it more in the middle. So 76,000-ish. Okay, it's a little above that. That's our y-intercept. Okay, so that's year 0, right? So years since 2010, this is actually 2010. This would be 2011. This would be 2012. This would be 2013, etc. Okay. And now it's going to go down 1623 over 1. So I'm not really going to draw this very well because nothing is to scale. Oops, it should be going up, right? Because it's a positive slope. Okay, so every year they sell more shoes. That should be through the dot. Okay, but at least we kind of have an idea. So interpret the parameters in context. Let's talk about what that would actually be. The 1623 represents the sale increases. So every year, how much money they make increases by 1,623. Okay, that's how much we go up when we go over 1 year. So up 1,623 in revenue each year that they keep selling shoes. Okay, and this number, 76,361, represents that in 2010, that's what the sales were. Okay, so that's how you interpret in context. Let's talk about another one. Let me get rid of all of this that's on my screen. Just erase. And we will do a second example that is another word problems that you have a little bit more context to what these mean. And I know these take practice of reading, so just take your time and we'll get there. So here we go. In 2013, there were 1.31 billion smartphone users. By 2017, there were 2.38 billion smartphone users. Write and use an equation to estimate the number of users in 2025. Okay, so this one's a little bit different. So let's think about if we were to put this on a graph, what would we put on a graph? So just like in the last one, we're going to have years. And this time we're going to have that 2017 is going to be here. And no, I would say 2015. I'm writing the wrong stuff. 2013, because that's what we have right here. We're curious about 2015, right? I'm just reading everything wrong, aren't I? Okay. We know something about 2017. We want to estimate about 2025. Okay. So what we do know is that there were 1.31 billion in 2013. I'm going to write that 1.31 billion users of smartphones. By 2017, there were 2.38 billion. So we're estimating that this is going up every year, and up by how much, we don't really know. So let's first find out how much is it increasing by. So for, let's see, our run, remember we have rise over run. Well, we can do rise first. So rise is going to be 2.38 minus 1.31. How much did we go up? We went up 1.07. Okay. Now our run is how many years that took. So 2013 to 2017, that's 4 years. So we're going to figure this out. This is going to be our slope. So 1.07 divided by regular 4 is 0.2675. Let's use 0.27. That's our slope, or our M. Okay, because we need to write an equation. And our y-intercept is this. So we've already got all that we need. So y equals 0.27x plus 1.31. Now, to estimate how many users there were in 2025, we need to figure out, well, what year even is that? What is our x going to be? Okay, so 2025, how many years has that been since 2013? 12 years. Okay, so our x direction is years. That means I can plug 12 in right here. So y equals 0.27 times 12 plus 1.31. So I'm going to put that in my calculator, 0.27 times 12 plus 1.31. So we would estimate this equals 4.55. So in 2025, we would estimate the sales would be off my chart and way up at 4.55. So that's how you're doing this kind of problem. This one is a little bit extra. So if you're not feeling super comfortable with it, I understand, but please ask for help if you do want to try to understand, or I can give you a few more examples. Finding